For decades, instructional design has relied on a very specific assumption that reading in hypertext improves learning because it mimics human associative thought. The theory suggests that clicking seamlessly between related ideas allows students to build more complex mental models. But early studies into how humans actually read digital text revealed a persistent problem. Researchers identified a behavioral pattern known as the "what's behind the door" syndrome, a hesitation in the reader's flow caused by the unpredictability of where a hyperlink might take them. When interviewed about their study habits, students report that reading online is slower and more tiring. Rather than feeling liberated by endless navigational options, learners frequently describe a feeling of spatial disorientation. They get lost in the documents. These results are independent of technical proficiency or a user's initial attitude toward computers. In studies measuring satisfaction, students enjoy reading hypertext just as much as physical paper. The friction is a byproduct of the medium's cognitive demands. The act of reading carries physical, perceptual, and time constraints. For tasks that require analyzing multiple documents in parallel or extensive note-taking, a printed artifact remains more practical than a screen. The digital environment, despite its speed, can actively work against deep focus. Since clicking through links routinely causes cognitive friction, we have to ask why higher education continues to push complex study materials into nonlinear digital environments. The answer lies in a specific academic skill called intertextual integration. This is the ability to read multiple, often conflicting documents and synthesize those disparate facts, concepts, and theories into a single coherent understanding. Hypertext has the potential to facilitate this high-level integration, but only under specific structural conditions. Without explicit cognitive scaffolding, nonlinear navigation leads to cognitive overload rather than knowledge construction. To understand how digital navigation is supposed to work in an academic setting, we look to researchers Jacobson and Spiro, who applied cognitive flexibility theory to teaching complex, ill-structured subjects. Their approach relies on crisscrossing, having a student reread the same concrete case study multiple times, analyzed through different thematic lenses. Rereading the text from new angles forces the student to map isolated cases onto a wider, abstract conceptual network. This environment assumes the learner views knowledge as a complex, interconnected web, rather than a collection of simple facts. If a student believes learning is just about finding the right answer, they often fail to commit the cognitive resources needed for this type of deep, multi-perspective processing. While hypertext provides the technological environment for crisscrossing, it requires rigorous testing to see if learners actually navigate in a way that builds these conceptual maps. To test this, researchers designed a study to see if hypertext helps students construct argument models about the building of the Panama Canal. Students were given 20 minutes to study a set of 9 documents concerning the historical controversy of the Panamanian Revolution. Their task was to untangle conflicting interpretations and figure out exactly what happened. This digital table of contents shows the intended hierarchical structure of those documents. The reading materials mapped from factual textbook passages down to accounts from historians who disagreed with each other. These arguments relied on primary evidence, like memoirs from revolutionary leader Philippe Bunau-Varilla, suggesting the U.S. helped plan the revolt. The researchers tested 2 presentation formats, a sequential page-by-page linear presentation and a structured hypertext presentation. Both groups were given access to this hierarchical content map, which outlined the relationships between the sources to help them build their mental model of the controversy. But the hypertext group had a unique navigational mechanic. As seen in this document, students could use an embedded Hey icon link to instantly jump between a historian's claim and the primary evidence cited. The researchers hypothesized that this functional, associative navigation would make the relationships between claims and evidence more salient, facilitating a deeper understanding of the argument. By using direct links to crisscross between documents, the hypertext group was expected to build more coherent argument models than the linear reading group. That expectation was not met. The structured hypertext presentation did not improve the students' understanding of the argument model. They performed at the same level as students paging sequentially through the linear format. To understand why the expected benefits failed to materialize, the researchers analyzed the students' study strategies. This graph compares reliance on the table of contents versus direct links. Left, the linear condition, shows stable, low reliance across both problems. Right, the hypertext condition, shows a massive shift. By the second problem, these students nearly doubled their table of contents usage. This reveals that as the task progressed, students in the structured hypertext condition actively abandoned the embedded associative links. They stopped using the study strategy they had been explicitly taught. Instead of crisscrossing through the material via contextual links, the learners retreated to the most rigid, global navigational tool available to them. What drove this sudden drift away from associative linking? The data points to cognitive overload as the primary cause. Providing dual navigation systems, direct links alongside a global hierarchical map, forced users to maintain conflicting cognitive representations of the information. Their brains were trying to reconcile a node-to-node route map with a top-down survey map, creating friction in their working memory. When working memory is overwhelmed by conflicting spatial models, learners default to the most structured navigation tool available. They use the table of contents as a way to anchor themselves. The physical presentation format of digital information is secondary to the design of the task. Placing embedded links inside a text does not automatically ensure that a reader will construct a meaningful argument from them. To facilitate the synthesis of multiple documents, digital learning environments must be designed to minimize unnecessary cognitive load. Building a functional argument model relies on specific scaffolding, like persistent global maps, that helps learners manage the information's complexity without getting lost. Effective digital pedagogy depends on these anchors to support the deep processing of complex documents.